Yeah, Levi, erase that blob.
Oh, you caught me. I'm in the hallways of Harvard and working on a very complex math problem. I must be very smart.
You need therapy from Robin Williams.
Yeah, but I'm gonna reject him at first and be mean to him about his passed away wife.
Those are your defenses from your rough childhood.
Right, but it's not my fault.
It's not your fault. Hey, it's not your fault.
Stop it.
Don't you know
Stop it.
that it's not your fault?
Stop. Oh!
Do you get it now?
Yes, all my problems are fixed.
That's all that it takes.
Then you make a movie about it. That was actually their relationship in real life at the time.
No way.
Oh no.
You know, I didn't realize that it was about a guy named Will Hunting. I thought it was like, hey, you're gonna go hunting? Here's Goodwill. I didn't know. I just didn't know.
You just didn't know. It's not your fault.
There was no way for me to know. Don't you see that?
I see that. I also see that every time you exhale, the breath goes out the eyeball holes of that mask and fogs up your glasses.
Well,
I really hope they can see it, but unlikely.
That's how lions work.
Oh, they breathe out of their eye holes?
Yeah, did you not know that?
I didn't know that, but it's not my fault.
What do you think about the two of us doing a sick dance break?
I feel pretty good. 1, 2, 3, go!
You've got to do better than that, Mr. Levi. Are you okay?
I'm okay, but my marker's not.
You're ruining the dance break. 7:30 to 9 p.m. Eastern Standard Time.
1, 2, 3, let's go.
What do we got?
Hello! How are you?
Time?
It's time!
Oh, jeez.
It's time!
It's time. I gotta close the door.
Close the door.
Hold
door.
Hold door.
We got it. We both got it at the same time, Bert.
Can we just hold door?
Can
we just hold door? No one's watching, because they never do in the beginning. That's great for a stream.
Excuse me.
Let's get on all the important things. Get our Discord here.
The Discord, my lord.
Discord word.
It is open, my lord.
Very good. Let's get this thing full screen, huh? Very good. All right. Give us your questions. I'm gonna
Give you money.
I'm gonna be right here. I'll be drinking water. The stream has begun. Hydration. It's important.
It's what's for breakfast.
It's what's for breakfast as well. That's the point of breakfast, is to hydrate. Levi!
Yes, Bert.
We got a viewer!
Oh, we got a viewer.
We got a viewer.
How many? A live one.
Speak. Whoever watches. Send something. Let us know you're real. I see the 1 on the screen. I know you're watching. Let us know who you are, coward.
Peasants.
Are you here to learn about the SAT and the ACT and how to improve upon it, or are you not? You must make a decision. You must. We are here for you, not the other way around. You are not here for us. But for right now, we would like you to say something. Because we see something, and we all know that if you see something, you should say something. Excellent.
Excellent.
Because it's Wayne's World, party down, excellent. Ooh. You never seen Wayne's World, have you?
No, have you?
I have. They do a public access show out of his basement, and it makes me think that this is kind of like Wayne's World.
This is publicly accessible.
Yeah, it is. Yeah.
Would you say that the stream has gotten worse since we started marketing?
It does kind of seem that way. Interesting. Maybe there's this dip that you take and then you slingshot out of it.
Like
You end up right where you started.
this type of thing?
No. Or there's not a literal slingshot.
Oh.
It's more like, you know...
Was that metaphorical, what you
It's
said?
a sci-fi movie. You're in a spaceship. You realize because of some space chase, you don't have as much fuel as you need to get back to Earth. And you're like, oh no, we're screwed. And then one of the people on the ship realizes, wait a second, we could use Jupiter's gravity as a slingshot to get ourselves back to Earth.
Oh,
they're
so
always
it's...
like-
and the guy who figures that out, is he
Or
a
she.
rapper? Is the actor who plays that character a rapper?
I mean, it could be.
Oh.
Interesting.
Yeah.
Is there a specific movie you're thinking of?
The Martian.
Oh. Who was in that?
Matt Damon?
Is he a rapper?
No, but he wasn't the one I was talking about.
Right. Who's the rapper?
Mars. The god of rap.
Ugh. Is there actually a rapper in that movie that's
Yeah,
acting?
yeah.
Who is
it's,
it?
Childish Gambino.
Donald Glover is not in The Martian.
Yes, he is.
He plays one of the people on the ship?
Or it's one of those other... It's like the movie that came out at the same time as The Martian. Pretty sure it's The Martian.
Okay, let me check on this. There was Chiwetel Ejiofor.
Nope.
Are you sure?
Then it's not The Martian. It's another movie.
Hold on. Donald Glover. He was in The Martian?
Boom, baby.
Wow.
He was the NASA son. See, dude, I watch so much TV.
You didn't even see The Martian.
I did see The Martian. I was there. It was based on my birth, actually.
There's a hair on my sandwich, but it's my hair, so it's okay.
Does this help?
No, it doesn't. We still have that viewer. That
Oh my
lone
gosh.
viewer.
I'm gonna go to the SAT Discord.
It does seem like, since we started marketing, the stream is just... Oh, wait a second. We got two. We got two viewers.
I think what happened is we stopped being able to do everybody's questions. You
Mm.
know?
You mean because they're copyrighted?
Yeah,
Well, at this point, does it really matter?
I guess not. No, we could get in trouble.
Mm. Very true. Next to the microphone. Yeah, it'd be good for the viewership. Chemist! 7:30 a.m. All right, a lot of stuff here.
Were you not in public school before?
Yeah, is this your new school? This is interesting. You finished art class and econ class, like they're done now. You don't have them anymore. Was it finals? I was in homeschool. Oh. Is this the first day that you will be at public school? Got it. Slayer Darth,
Slayer.
welcome. No. Okay, here in the moment, everyone's showing up now. Look at that.
Very nice.
It just takes a little bit, you know?
Yeah.
Hello, everyone. We're excited to see everyone. I'm eating a heck of a sandwich that's from the grocery store down the street. And that's all it's from. Nothing more particular. Mmm. Wait, look at this. Slay Darth has 417 nonfiction books on his phone now. And then, Slay Darth, you were able to somehow... Hip Chocolate Chip! Remember the person whose name we couldn't say?
Oh, should we say? Well, now we
We
can.
can say Hip Chocolate Chip.
No, but
Yes.
we can probably say the previous name too.
No, we can't.
That's
No.
what, no, I'm sure
No.
that's what they're saying.
No, they're not.
Okay.
How's it going? We are doing fine. Hey, Chemist. So wait, did Slayer Darth somehow get the books to you? Did you send... Don't worry, we're not going to say it. Did you send the books in the mail or something? Or was it... Oh, it was probably digital books? Digi books, digital book words. So we're going to say
Book
that?
words actually makes a
Yeah.
lot of sense.
Yeah.
Google Drive. Dude, Google Drive is the name of that self-driving car that Google's made.
Yeah.
Yeah, you put it in one of those cars and it drove its way across the ocean.
Yeah.
Across the pond, as us Kiwis say. Google, the most trusted service provider out there.
Even Apple uses Google.
Yeah.
Little known fact.
No ICT questions I have to say for another test. Here in the moment, but you're here in the moment. What kind of test do you want to study for? Maybe we could help. Yeah, most probably doing my math and English classes. I've been watching the televised impeachment proceedings. Interesting. It makes for very, very interesting.
I'm sure if we just streamed that, we'd get more viewers. Well, thanks.
Flat Earth. You know what's fun? Switch on different news broadcasting channels. Just to see how different the stories are in both of them. Or basically listen to Fox and listen to the other ones. It'll be like two different countries. Here in the moment, how's calculus going? We tutor calculus. If you got a calculus question for us, we got nothing better to do. I'm eating the sandwich, of course. Nothing goes down better with a sandwich than some calculus. And I've always said that.
Ooh, can you give us a practice problem?
I can make one up.
I want to do it though.
Do it.
Let's keep it simple. One here in the moment.
I can give you a practice problem. Ready?
Okay. Yeah.
All right. 3xy equals 2x plus sine of y squared.
Sine of y squared or sine of y squared?
Y squared.
Okay. Oh my gosh. Have I already forgotten how to do this? Probably not.
You want me to do it?
I think I should be okay. Okay. So you're going to just treat. We'll be watching you guys since Midnight Duck said his stream will be late since he will be visiting his uncle. What's Midnight Duck? Who is that? What is Midnight Duck's stream normally? Yeah, we hope his uncle feels better too.
So maybe
Chemistry help. Oh, cool.
really chemist. That makes sense.
So on this, you're basically going to treat y as another variable, but when you take the derivative of y, just write it as y prime. Would you say it that way?
Well, you're going to differentiate y normally, and then whatever you end up differentiating it, at the end of that, you tack on a y prime. So if you had like 5y squared, it become 10y times y prime. So it's not just throwing a y prime. You're going to differentiate it normally and then a y prime.
So this, you're actually going to use product rule. So this is going to be a 3 out front. Make sure I'm doing this right, Bird. I forget already. So it's going to be 3x, and then, well, let's do
Split
product
two
rule.
functions. Yeah.
So we have 3 times First, we're going to do the derivative of this times y. The derivative of 3x times y, because we're doing product rule, is just 3 times y now, because derivative of 3x is just 3. Then we're going to do product rule, which means we're going to add 3x times the derivative of y, which we're going to write at the moment as y prime. Now, next part, this 2x will just become 2, and then this sine will become plus cosine, because that is the derivative of sine. Cosine of y squared times y prime.
No. Chain rule.
Oh my god, sorry. Times 2y.
Times y prime.
Times y prime.
Yeah.
So, my bad. So chain rule tells us we have to do derivative of sine, which gives us cosine. Have what the inner function is, that's fine. Then you have to take the derivative of y squared, which is going to be 2y. We'll do power rule there. And then exponent rule, power rule. Power rule it's called, right?
That was power rule, yeah.
And then times y prime. Does that make sense thus far, here in the moment?
I just bit my finger.
Why?
I was biting the lettuce, and then there was a finger underneath the lettuce.
Oh, okay. Did it come with a finger?
I think so.
That's good. This is slightly cockeyed. Oh wait, no, it's not. The computer screen is cockeyed. Oh no, it is. It is. Okay. Y is sine of y squared cosine y squared times 2y.
Chain rule.
Chain rule. So if you had, let's say you just had sine of x squared, derivative with respect to sine of this would be cosine of x squared times 2x. Right? That's chain rule is if you're taking the derivative with respect to x of f of g of x. Oh boy.
Yep.
3 of those. That will be f prime of the inner function. You don't change the inner function there, and then you multiply by the derivative of the inner function.
Perfect.
Does that make sense?
So
this is the next step up from there, because then you have the y prime as well.
Right. If that's new for you, or if you haven't understood that fully, then this is going to be even crazier. You guys should have done, if you're doing implicit differentiation, then you guys should have done chain rule at this point.
My feet smell so bad.
Why?
Because I haven't changed my socks.
You don't know that for sure. Wait, you said that this morning. You still haven't changed your socks?
Here's the thing. I have a hangnail, like the middle toenail on my left foot is split in half.
Sure.
So anytime, like I have to sleep with one sock on. I don't like sleeping with socks on, but I have to sleep with that sock on because otherwise while I sleep I like kind of move my feet and then my toenail gets caught on the sheets or whatever and it rips the toenail out.
Right.
Extremely painful and then creates more of a problem until that rest of the nail grows out and then it's full again. So I have to keep on the sock while I sleep and then I just don't remember to
Why don't you address the nail? The nail itself.
I don't have a hammer.
Cut it. I understand the hammer joke. Nice. Cut it. A nail file. I mean, get rid of the sharp edge.
It's too deep. Like it's split too deeply into. Like it's into the.
Yeah, I get that. I get that. Okay, so we're talking about something like this. So this thing kind of goes that way.
Yeah, that's a little small.
What?
My toenail is much bigger than that.
Oh. I'm sorry about that.
You're so scared for tomorrow. Be not scared.
Repress and dissociate. So you got this split, right? Yeah.
Sure.
No one's asking us questions.
Yeah, why not?
So yeah. So, okay. There's this sharp edge right here.
This is also more important.
And here, right?
Yes.
Nail file.
Yes.
Get rid of the sharp edge of the nail file.
No, but so it's also, like, part of it is raised here. Like, I can't get rid of that.
Okay. Can I see it?
No.
Oh, they completely covered it.
Oh.
Quantum computing, welcome!
Quantum computing was here last week.
That's very good. No, I mean, I know that. I'm just saying it's good to see you.
It's one of those shirt tattoos.
Here in the moment.
You can tattoo a shirt and then wear that shirt, but, take it off and wash it.
Yeah, you can do that.
It's like that. Here in the moment. This thing here. How do you feel about this? Because we're not done yet.
This is going to be another chain rule situation. So what you have here is whenever you have radicals in calculus, turn them into exponents because you can do power rule much more easily. So this is the same thing. Second to the 1/2 power is the same as the square root. So we have overall we have this exponent situation and then that's good. And then we have inside another function. So we first address the outside. We have something to the 1/2 power. We're going to do the power rule. So this is going to become 1/2 4x plus 1 to the negative 1/2. And then we take the derivative of what's on the inside. Derivative of 4x plus 1 is just 4 times 4. And then you can clean it up if you want, depending on what your teacher wants. I love cleaning it up. 1/2 times 4 gives you a nice solid 2. 4x plus 1 to the 1/2 means it's on the bottom and it's a square root. So we have here negative 1/2. Sorry. 4x plus 1. That would be the way to do it.
The way to do it.
Yeah, the way to do it.
Right, so anytime.
Yeah. Sorry.
Very loud in my
That's what we do in the down under, in the outback steakhouse
kangaroos.com
For you.
and
Kangaroos.
our viewers. Oh, that's good.
How do you isolate y in the equation above? Yes. Okay.
Oh,
Good.
baby.
We have not actually gotten to that point.
That is a factoring idea. So from here, this is the implicit differentiation part, and then from there we can just solve for y part. What net for? Okay, so we'll have Bird do that part. Also, do let us know how, and everybody let us know how you feel about this and the conversation surrounding it. That's also very important for me personally. So the goal here is to find the derivative, right? We have the derivative in this function. We just need to isolate it, right? So let's not use blue because I don't have the blue marker here. Our first step is to get our y prime terms on the same side. So I'm going to pull this whole term over here and take the 3y and put it over there. And we will get 3xy prime minus cosine, could have made it better, but whatever, y squared times 2y times y prime equals 2 minus 3y.
You do calculus on that side, I'll do figures on this side.
Oh, we are well, Boss Dad. How are you?
Boss Dad.
Woo! Boss Dad had a good joke, a really good joke the other night, right? What
Really?
was it? Yeah, it was last night, dude. Do you remember?
I never remember.
Boss Dad, what was your joke that at least I liked and have since forgotten?
Here in the moment, F equals manoob. That's correct. Yeah,
Um,
chemist. It's Newton's second. F equals ma.
Okay, now from here we're going to factor out the y prime. If we pull out the y prime from this term and then this term, we'll get what's left over. So we have y prime times quantity of 3x minus, it's okay, Boss Dad, I forgive you, 2y cosine y squared equals 2 minus 3y. Yeah, here in the moment, Chemist makes a good point. Very good point.
Newton did do alchemy. He was a big believer in the occult and kind of spooky stuff. And like
Here in the moment, how are you feeling about
skeletons.
this? Because now the last thing we do is we just divide by this whole guy here. We get y prime equals, so the derivative of y, which is what we're going for in the beginning, is going to be equal to 2 minus 3y over 3x minus 2y cosine y squared.
We can do an easier one too. Because yeah, there was a lot of stuff. I mean, it'll probably be that difficult on your test.
Can you give us your example? Because we can also do that. We got it. Yeah, let's do one more just to, or work through one more, and then give us the question. We will work through it, and you can compare your answer. And you can do that while we're doing chemistry stuff, physics stuff.
So, Mr. Chemist, 1902. That's supposed to be an M. Newton's second law tells us the relationship between force, mass, and acceleration. It's usually written in terms of F equals ma, but it's actually better understood as A equals F over m. We can talk about that in a sec. It's just plug and chug. You want to find the force? That's what this is. Net force is F to make a mass of 5 kilograms go at acceleration of 11 meters per second. You just put this in for m, you put that in for A, and you get 5 times 11, which is going to be 55 newtons. Newton himself. I just did my mechanics exam today. I love mechanics. Like physics mechanics, or like you're going to be a mechanic. They're related, but they're not the same thing. Can you go over tangent lines, actually? Why multiply? Chemist, the formula is F equals m times A. This is multiplication here. When you have two letters next to each other like that, that implies multiplication. It is just the language of mathematics. Okay. You want to go over tangent lines? Equation of tangent lines.
So tangent line equations are, there's very little math involved beyond the derivative. It's just normal line stuff. So let's say this is our curve here. If you are trying to find the line tangent to the curve at this point, you would find the derivative.
Your lines look incredible right now.
They do.
Yeah.
That's cool. So the derivative here is going to be f prime of, let's call this point C, right? So this is going to be f prime of C. That's the slope, right? So then you're going to use y equals mx plus b. You know this point C, right? You know that point. So if you plug C in for the original f of x, you'll get a point. Or so you could do point slope form. That's probably better than this.
It's the easiest, yeah.
So do point slope form. You have the y minus y1 equals the slope, which is going to be f prime of C, the slope times x minus x1. Would you like to see an example of this, or does this clear it up for you?
I think got a specific question.
Oh, what if it gives you an equation and tells you to write an equation at an x point? Yeah, we can certainly do that. So let's say the function is...
While you're setting up, can I talk chemist?
For sure!
Sorry.
For
Okay,
sure.
chemist. So, an object will continue moving. An object that's moving will continue moving, and an object at rest will stay at rest unless acted upon by an unbalanced force. If your motion is changing in some way, that means that there is an unbalanced force on you. A balanced force would be like, right now I'm not moving. Gravity's pulling me down, which is a force, but then the floor is pushing me up. Because of those balancing out, I'm not going to go anywhere. If I was moving, if I was falling, then there'd be an unbalanced force on me. And falling, specifically accelerating. So if this wagon is going at a constant speed, that means it's not accelerating. If your speed is changing, then you're accelerating. But because there's no acceleration, there is no net force. Okay? There is a force pulling it and a force pulling it backward, namely the pulling force and friction, but they have to cancel each other out if the wagon stays at a constant speed. That is essentially the same thing as staying completely still. So that's the first part of your question. Go ahead, Levi.
Okay, so we have this equation f of x, 3x squared minus cosine of x squared minus 1. We need to find the equation of the tangent line at x equals 1. I have no idea what this graph looks like. I really don't. So first we're going to take the derivative, which brings into, we're not doing implicit differentiation, but there is a bit of chain rule. So f prime of x will be equal to 6x, and now derivative of cosine is negative sine, so it'll be minus the negative sign, so it'll be plus sine, and now here is chain rule. We're going to keep that inner function, but now we have to multiply by its derivative, which will be 2x. So now this is the derivative of our function f.
Which again that is the slope of any particular point.
This is the slope of any particular point of this function. So the point is 1, so we need to find, oh no, let's do it here. We need to find f prime of 1. This will give us the slope at x equals 1. So we just plug in 1 for all of these things. We get 6 plus sine of 0 times 2. So this will be sine of 0 is 0, so that goes away. So this is easy enough. F prime of 1 equals 6. So that is our slope. That's the hardest part, I would say.
Goodbye, boss dad.
Bye, boss dad. Mwah! Boss dad has tucked us in, kissed us on the forehead good night, closed the door.
Gently frothed our brows.
What?
Boss dad has gently frothed our brows.
What is that?
I don't know. Boss dad did it, don't look at me.
That's true. Anyway, we have the slope now. That's our slope. So in our equation, we have 6, right? That's going to be the slope. We're going to have y, and we know we have our x here. Now, we need to find, that's not a good place to put it. We know the slope of our equation is going to be m equals 6. Now we need to find the point. Well, x is 1, so we need to find the y value of the original function. Because we have, let's say this function looks like this. We know that here's the tangent line, we have the slope, but now we need to find, we just need the point. So let's find the point. We say f of 1, we're going to plug in 1 for the original equation, and we get 3 times 1 squared is 1, so whatever, minus cosine of 0, which is 1. So we have 3 minus 1, which equals 2. So now we have the slope is 2, and we have the coordinates, which are 1, and then the y coordinate is 2. So now we have everything we need. So it's going to be y minus 2 equals 6 times x minus 1. And you can put that in any format of equation that you'd like. Does this whole deal make sense to you?
Chemist. So we talked about the net force is 0. Brady's teacher's pocket is higher than Levi's. You don't necessarily know that. Maybe that's true. So the net force is 0. What is the value of the force of friction acting on the wagon? Well, if this wagon is being pulled with a force of 25 newtons, so this is the pulling force, and then the force that resists motion is friction. And we end up with a net force of 0. So net force, all the forces added together end up making 0. This thing completely cancels out this thing. Therefore, friction must also be 25 newtons. If it was not 25 newtons, there would not be a... Well, Levi is shorter. That might be something.
I am shorter, yes. So the pocket on the shirt is right where it's supposed to be, but I'm not as tall as Brady.
Yeah.
Which is...
What? I can froth your brow if you want. So friction is going to be 25 newtons also.
Make up your mind, computer.
Okay, the last thing. If the force on the box increased to 30 newtons, use Newton's law to explain what the effect would be. Okay. So if we now have 30 newtons on the box, that would not change our friction force. Our friction force would still be 25 newtons, which means we now have a net force that's not 0. Our net force, if we add up all the forces, would be 30 minus, because this is going in the negative direction, 30 minus 25 is equal to 5 newtons. There is now a 5 Newton force on this box. And because that is a force, yeah, you got it, exactly, it's 5, we're going to experience an acceleration. So it's moving at a constant speed until we increase the force. Now it's going to start speeding up. Logarithms. How can I remember all the derivative rules? I have trouble with logarithms. Just logarithms in general, or logarithms when applied to calculus? If you were both the same height, Braves would be lower, as in the pocket is situated lower on the t-shirt. Quantum computing, that is impossible. These are literally the same exact shirt. Levi and I are trading it faster than you can even see, back and forth. So it's the same shirt. If you had a slow-mo camera that was like 12,000 frames per second.
And if you were very stupid,
you would see that we're switching the side back and forth. Okay, the shirt, back and forth. So what you're saying is literally impossible.
Brady is a very passionate business partner.
Absolutely. I'm very passionate.
You good here?
Yeah, go for it. How do I explain the Newton's law effect in that? Well, it would experience an acceleration. That's what this is. So like F equals ma, you can all this stuff except for this stuff here. F equals ma. The thing that happens first is you put a force on an object, and then putting a force on an object will create that object in acceleration.
Sorry, what?
So keep these two things, get rid of all this stuff. You put a force on an object, it's going to accelerate. It's not like it happens the other way around. I mean, I guess you could see, oh, if this object is accelerating, there must be a force on it. Yeah, that's true. But in terms of the way that humans think, this force on my hand is going to create the acceleration, okay? So what really is a simpler way of thinking about it is an acceleration is equal to force divided by mass. If you increase the force, the acceleration will increase. If you increase the mass, the acceleration is going to decrease. This is what an acceleration is caused by. So it's proportional to the force, and it is inversely proportional to the mass. If you're pushing a little car, if you put more force into it, you're going to make it accelerate faster. And if the car is heavier, it's going to be harder to get it to accelerate, so the acceleration will be lower because of that. I don't know about that.
let's just move on.
Okay.
Okay. So here in the moment, you have trouble with logarithms, so logs and calculus. Oh, he did say, okay, great. Just a little bit too much. It's fine. So let's do, if we're doing the derivative of, let's say f of x equals log of x. What is the derivative of log? Wait, what is the derivative?
Haha.
We should just do the derivative of natural log.
Yeah, I gotta look this up real quick. It's a derivative of log.
Generally, generally you're doing the derivative of the natural log. I have never not done that.
You can do derivative of log. Okay.
No, I know. I'm just saying, like, every
Here
time
it
I
is.
do.
It's ugly, right? So log a of x. So for natural log, go ahead and write that 1 over x.
Natural log of x, derivative of this function is 1 over x.
That's always a nice one. And then if the function is log base a of x, so there's some a value, you're taking the log of x, then g prime of x is equal to 1 over x times the natural log of a. Which is why you end up with this. If you put e, so, natural log is log base e. So if you put e in for this, you take the natural log of e, that's going to end up giving you 1. So you just end up with 1 over x. But if it's not e and it's a, that is your derivative of log.
So there's a lot of stuff clearly on this test for you tomorrow, but this is just memorization, and then you insert it into whatever product rule or quotient rule or chain rule that you have to do.
Chemist, it's literally just plug and chug. This is your formula. The things they're giving you, you put those in for those variables, and then there's only one variable left to solve for. So in terms of F equals MA, what things do you know and what do you not know?
Oh, sure. So let's say that your function is... Bird, give me a function with natural log in it, please.
It is 5 times the natural log of 3x. Okay, so you're saying it's going to be 5 times 10. So you'd be taking your mass and you multiply by your force. No.
You want to figure that out while I do this?
Acceleration, 10 times 2. Okay, well, let's see. The net force is 10. The net force is 10. We don't know the mass. The acceleration, they say, is 2. They gave us the force and they gave us the acceleration. So that's what we plug in, and the one thing we have left to solve for is m.
FastX, how are you? FastX, are you in middle school? Or am I remembering a different username person? I forget. It is product rule. Yes. Well, no, sorry. It's not product rule. My bad here in the moment. It's not. Because product rule is when you have two functions multiplied together. So if you have 3x times sine of x. This is product rule because you have two functions. Think of these as functions. This is an f of x, and by function I mean anything that's being done to x. Okay? So you have this function, 3x, and then you have a different function, sine of x. This will give you product rule if you're multiplying two different functions together. Chain rule is when you have, do I have room here? Chain rule is not like this. Chain rule is when you have f of g of x, which is like what we have here. We have natural log of a thing. That's our outer f of something. You're just playing. Oh, that's that part. I see. And then the outer function is f of something. That's natural log of something. The inner function g of x is 3x. So you have two functions, but they're not multiplied together. There's one nested inside the other. So that means
right there. Keep going.
When you nest functions, you have to do chain rule. So this will be the 5 just stays there, and then we're multiplying by 1 over what's in here. That's the derivative of natural log normally. So you have 1 over 3x, and then you have to multiply, because of chain rule, by the derivative of the inner function. I'm going to sneeze, which is 3.
Okay,
So when you put this together, sorry, you just get 5 over x.
Chemist, where is the 2 from? You got a 2. Where is the 2 from?
Why not from the 3, my lord?
Very good. Because you put a 2 in there, I got 15 over 3x.
You didn't simplify. That's all. You did your calculus fine.
Wait, chemist, that was for the previous problem. I gave you a different problem here. So there's a new problem where the force on an object is 30 newtons. The acceleration it causes is 4 meters per second. What must the mass be? So it's not divided by 2. Yes, there you go. Yes. So here's what you should have just done. You see that our force is 30. So that's what we put in for F net. That's going to be 30 is equal to, we don't know the mass, so we're just going to stay m. Our acceleration is 4. This right here needs to be where you go with every single one. You put in the things that you know into this formula, and then you solve for the thing that you don't know. You gotta do implicit with the logs.
Yeah.
Here in the moment, we also tutor calculus, which I guess is which unbalanced force against your direction of that force of the rocket. Chemist, all right, which unbalanced force accounts for the direction of the net force of the rocket? Air resistance, friction, gravity, thrust of rocket engine. Well, whatever your net force is what directs you in the direction you're going. That's the force that wins, basically. So think about the direction a rocket goes. A rocket goes upward. What force is causing it to go upward? Is it air resistance? Is it friction? Is it gravity? Or is it the thrust of the rocket engine? Why is the rocket going upward?
I'm trying to think if this is going to ruin everything if I do it this way. No.
Yeah, there you go. Exactly. Yeah. That is the force that, even though there's these other forces, it overpowers them. It's not canceled out by them. It's somewhat lessened by them because, you know, you're going up and then there's this force pulling you down. But overall, you have a much bigger force going upward, which is why the rocket ends up going upward in the first place.
Okay. Here in the moment, there's a lot of stuff going on in here. I do apologize for the consistent slight upward tilt of all of my writing.
Chemist,
Done.
you should know how to do this now. Chemist, write F equals ma. Put those numbers where you think they go. So don't just think in terms of what do we do in the last problem. The approach is always the same.
Okay, so here in the moment, for this one, there's a lot of stuff going on. Is that the product rule and chain rule? Yeah, baby. It's product rule, it's chain rule, it's natural log, and it's implicit differentiation all at once. You can do... Well, okay, so the product rule is how you take the derivative. The chain rule is how many times you'll have to take the derivative. So in this case, you're going to do product rule first. You can think of it that way. In this case, we have a function here, right? This is a function, just the x here. Then we have a function here, the natural log of a thing. And then within that, we have another function. So we'll do product rule first. We have the derivative of this times that, right? It's the first thing, derivative of the first thing times the second thing. So that's simple enough. Derivative of x is just 1, so we'll get natural log of 2y squared. And now product rule tells us to do now x times the derivative of this. So x times the derivative of that is x times 1 over what's in here. Now we're going to start doing chain rule. We're taking the derivative of this thing, which is nested functions. So we have 1 over 2y squared. Now we have to take the derivative of what's inside the parentheses here, because now we're doing chain rule. So we'll have times 4y We just pull that exponent down. And then we also have to do with respect to x, so we'll just get times y prime. That's the implicit part. And now we go to the other side. Is everything on this side okay? Please, let's talk about this. I'm happy to talk about this side. There's no point in doing the other side because it'll just confuse you if you're not good with this side. How do you feel about this? Could you get my charger in my bag there? My phone charger?
Where in
It would just be in the main pouch, just on the floor of it.
main pouch?
Main pouch.
Put
on your main pouch.
today.
For you. If it's not, it's a white cord, so you should see it if it's there. No good?
No dice.
All right. Here in the why is it not natural log of 2y squared times y prime? Ah, okay. Because in chain rule, you have to do in chain rule, let's just write this. We have this, and then we have the derivative, which is f prime of the inner function times just g prime itself. So in this case, you're good. You're fine. You're fine. Don't worry. Don't worry. We're getting through it. So we have this, right? It's the derivative of the big guy. Don't change what's inside of it, and then multiply it by the derivative of the little guy inside of it. So in this case, this lines up with the natural log of 2y squared. Okay? Natural log of 2y squared. We're going to do the derivative of the outer function and just have the inner function there without touching it. So derivative of natural log is 1 over x, but it's not x in there, it's 2y squared. So we just have a 2y squared. That's this portion. Okay? And now we just have to multiply by the inner function, which is just the 2y squared, just inside there. That's your g of x. So we get 4y when we take the derivative of that. Does that help clear it up, or does that just deepen your sadness? Both are fine. How do you feel? Okay. And this is a very complicated problem. I'm happy to drop down to something a little bit more straightforward. Okay, you get it a little bit. Basically, let's keep doing these nested functions. That's what we need to deal with. Get very good at that. So if you have sine of x, you can technically look at this as chain rule. It's going to be sine of the sine is the outer function, and then x is the inner function. You'd get cosine of the inner function times the derivative of the inner function. In this case, it's just x. What's the derivative of x? It's 1. So you can just totally ignore it. That's why we can ignore it when it's just sine of x. Now, if we have sine of, so this is going to take the derivative. Now we have sine of 2x. Well, sine of 2x, take the derivative of sine, which is cosine. Don't change the inner function. And then we have to multiply by the derivative of the inner function. The derivative of that inner function is just 2. So you get 2 cosine 2x. We can keep doing these if you'd like. I think this is probably what you need to practice most, so that you can then feel very comfortable with chain rule when you have to use it, when it's part of product rule. How you feeling? Okay, good. So now let's do this guy. Now this one, we have a function here, right? We have another function here, so we're going to be doing product rule. Now within this function, we have a nested function. So when we take the derivative of this guy, we're going to have to do what's it called? Chain rule. So product rule, derivative of the first guy times the second guy. We get derivative of this is going to be cosine of y. Now because this is implicit differentiation, when you do the derivative of this inner thing, it's just going to be y prime. So we have times y prime, just times the end there, so times cosine of 2x. And then we're adding, because product rule says derivative of this times this plus this times derivative of this. So we're going to get sine of y times derivative of cosine is going to be negative sine. So I'm going to change this out here because it's times that, so I'm just going to make it negative. Please let me know if that confuses you. Negative out front, and now we just have cosine, no, sorry, sine. Sine of 2x, and now that's the nested function, right? Derivative of the big guy, derivative of the outer function, will just be the negative sine, so we got that, times the derivative of the inner function, which is just 2. Now we have this whole big thing. We can simplify a little bit of it. Then you put your y prime terms on the same side, factor them out, divide by what's left over, and you are done. There are a lot of steps. You do not have to understand all of it at once, but you have to understand the pieces very, very, very well. I would recommend doing a ton of things like sine of 2x. Do that first 50 times with sine, with cosine, with tangent, with natural log, with normal log, with all of these different outer functions. You could also do something like what is 2x plus 3 squared. 2x plus 3 squared, the derivative of that. I got the y prime sine y times it's very messy. So y prime times sine y you should not have y prime times sine y anywhere. So we're this first part is derivative of this sine here, right? It's derivative of this times this. So derivative of sine y is cosine y. And then you do the inner function, which is y prime. You put an extra y prime. Yes. Do not take you weren't taking the derivative of sine of y here, so don't just start taking the derivative of y. It's just the original thing. This is a very complicated one. I really recommend doing 50. Do 50 of these. It will help you a lot. And I did the product rule in a different order. That's okay. You can do so. Product rule. If you have f of x times g of x, that's going to be f prime. I'll just leave it at that. F prime g plus f g prime. That's fine. Or you could do, it's the same thing as taking the derivative of the second one first. That's okay. You can do f g prime plus f prime g. You can do, that's fine. The order in product rule doesn't matter, as long as you do both pieces and you add them together. Oh my gosh, my feet smell. Okay. Good. I'm glad you get it. You just need practice so you're not freaking out so much. Bird, have you cooled down from that kid pissing you off today?
Yeah. Dude, Venice is like underwater.
Really?
Yeah.
Why?
There was a flood.
Oh, Venice. I was thinking about Venice, LA.
No. No.
Brady is surfing the web right now. And he surfed the web all the way to Venice because Venice is entirely underwater. Entirely, right? Is everybody just living in their boats now?
Yeah.
Wow.
Yeah, it's just all boats. No, but it's very sad. They need to. There's this massive, like, dam construction project that they're trying to get going,
that could protect the city for a while. But there's all sorts of like political corruption and things like that that have slowed it down.
Somebody's asking about you, Bird.
What do they say?
Why don't you come up here and check it out?
Is it good?
Yeah, it's not bad.
Really?
Yeah.
Okay. I don't know if I should trust you.
You have to trust your business partner, because if not, who would you trust?
That's very true. Did you say whom?
Yeah, I should.
Oh, no, it's not important. You shouldn't have said anything.
I didn't say anything.
Yeah, you did.
No?
Should I cooled off?
Oh yeah. Have you cooled off?
Yeah.
Dunked yourself in the Venice pond?
Just dealing with some difficult people. You know, difficult people. They know you. Yeah, it's whatever. I'm so scared for tomorrow, man. Here in the moment. You're gonna be okay. How to reduce test anxiety. Should I put on the Batman mask?
Put it in a saucepan and put it on a medium heat for a little while. Keep stirring so you don't burn yourself. And you can reduce it that way a little bit. Get rid of some of the water. Reducing test anxiety. Study the simple things. Make sure you know parts. You may not know all the pieces, and that's okay. That's what it's going to be. But if you have pieces of it that you're very confident on, it will help you. There is a certain point where your return on studying is not going to help. Like if you lose too much sleep, that's no good. It's the same thing for SAT day stuff. You can do sleep, eat well, drink water, that type of thing. Oh my gosh.
That's ridiculous. I'm Batman.
Oh.
What are you talking about?
Quantum computing, that was right at the line, and it was awesome.
So you think? You think that I'm not Bruce Wayne, but that I'm Justin Trudeau?
You
Is that
just
what you
gave
think?
yourself away, dude.
What? No. People have seen the movies about me. They all know that I'm actually Bruce Wayne.
Oh.
If you have test anxiety, you should watch an ASMR channel. N3rdish will now be an ASMR channel. Hello, you're watching N3rdish. You got any questions?
Is everybody okay with this?
You should be okay with this.
Do you like this?
It's ASMR. ASMR gives you high blood pressure. Yeah, but it's not about you. It's about here in the moment.
Oh, God.
Batman.
Oh, I hate
Math, ASMR, only at N3rdish. There's nowhere else you could get this. This is so good. Test anxiety. It's gonna be okay. You get a bad grade. It's not the end of the world. Is Levi Robin? Levi, are you Robin?
Yes.
Here in the moment.
Farewell, A and Calc. Farewell.
You need to be solid on these concepts and not rely on the last day before the test. If there's things that you're not solid on throughout the testing period, as in for the next 2 weeks until the next test, study them. Khan Academy, N3rdish, ask us for tutoring. We'll help you so by the time the test comes around, you're not scrambling to get your act together. I know that doesn't help you for this test coming up, but it's just one test. There'll be many tests before the end of the year.
Since nobody is asking questions here in the moment, we can keep doing stuff if you want.
Yeah, you want?
Do you want to keep studying?
You wanna keep studying? You haven't gotten integrals yet, have you? So you don't know that. Look,
Okay, take the derivative of that. Let me know what you get.
Sorry, there's a little bit of a delay.
Oh yeah?
Yeah,
Did your pixels get frozen?
yeah, it was buffering.
This is not the best way to use here in the moment's time. Here in the moment, take that derivative of that.
Derive.
Differentiate.
Huh?
Differentiate is the verb.
Oh. What'd I say?
Derive.
What'd you hear?
Derive.
I feel like there's some sort of disconnect.
Oh,
Cosine times cosine of
x. Cosine of cosine of x.
Cosine of cosine of x times negative sine of x.
Bingo.
Very good.
Very good.
There's no way to simplify that. That's just what it is.
Well
Good.
done.
What if you had...
It's very good. Batman approves.
What if you had this?
Where's Rachel? Harvey Dent.
Now what is your answer?
What's your answer now? Big shot.
That's terrifying. You look like a little doll.
Like on the screen or in your reflection?
And on the screen. 1 minute. Yes.
My reflection.
In the snow-covered hills.
Last light bring you down. See, I've been afraid. No, I've been afraid of changes. 'Cause
Yes.
I put my life.
That's a bone you gotta pick with Bird, and Bird picks bones. He's the early bird. Gets the worms.
And the bones.
Yep, he eats all the flesh off the worms until he gets to the bones of the worms. And he eats those too.
No, I use the bones as money.
Oh,
Worm bones it's now cryptocurrency.
okay. That's dumb.
Well, I mean, I didn't create it.
Yeah.
The worms have been using their worm.
Hate the player, not the game, right?
That's
Oh, no,
right, dude.
no,
And
no.
also, if you die in the game, you die in real life. Ow!
That's kind of cool.
It was a little bit.
Here in the moment.
Oh! What time is it? Quantum computing, be careful. You're kind of over the line sometimes.
I do want to hear a joke, as long as it's okay. All right, probably a good choice. Here in the moment, it's been more than a minute. Where have you been? Oh, we're sure it's funny.
Oh, that is pretty funny. Yo, what are you going to divide by ASMR with?
No, the derivative of this is not really long because there's no product rule here. It's just going to be, it's continuing to nest. So as we said before, f of g will be f prime of g times g prime. But if you have f of g of h, then that will be f prime of g of h times g prime of h times h prime. So it's slightly longer than last answer, but not by much.
Newton's third. Every action creates an equal and opposite reaction.
Yes. Oh, don't apologize. That's fine.
Stop.
Dude, I can hang you up by this.
I know.
That's great.
How do you think?
I got these scars.
Morgan Freeman. How do you think I got these scars?
No. There's like a little, where we bought this at the Halloween shop, there's a little, like, I don't know what shape that is. It's the classic shape that goes on the little hooks on the walls, you know? You just slip the thing on the wall.
Yeah, little known fact, Batman actually has that on his mask.
I'm mad at you.
Do you?
Yeah, I do mad at you.
Oh gosh.
Yes, the price tag is $2 bucks.
Wow,
Pretty cheap. You should get them now.
Yeah, I thought Nurse Bucks were wildly inflated now.
You know what, Bird?
Huh.
You're a little bit too loose with Nerdish bucks. It's not like Nerdish bucks grow on trees, all right?
Yeah, that's true. You create all the Nerdish Bucks, then you
Yeah.
give me an allowance.
I would, dude.
You do.
Yeah, I would. You know, wood actually grows on trees. Wood doesn't grow on trees, so I wouldn't. Let's see. We got cosine of 2x squared times cosine of... Careful. What happened to your sine? Derivative of this guy is sine, or negative sine. You're close. You're very close. You made a small mistake. Everything else is perfect, but you shouldn't have 3 cosines. You should have one of them should be a sine. Which one should be a sine? You're very close. Be not depressed. Wood doesn't grow on trees. Yes, perfect. That is the right answer. Do you have any questions about that? So that can you can keep nesting and nesting and nesting. And it doesn't necessarily get more complicated. You just don't take the derivative of anything on the inside until you get to that inside part and you take the derivative. So that's chain rule. So now if you had this times... So these are all nested, right? There's no multiplication here except for when you get in there. If you have this times, I don't know, natural log of, I don't know, you could say natural log of cosine of x. I assume you won't get anything this horrifyingly complicated, but you do everything you just did. That's the derivative of this times that. Then you do plus this times the derivative of this, which would be, the derivative of this specifically would be 1 over cosine of x, because that's 1 over whatever is in here, times whatever's in here, or times the derivative of this, which is going to be negative sine of x. And you go from there. So all of this stuff, and that's why I want you to practice things like this and then make them progressively more complicated rather than trying to do a giant, and I apologize for doing a giant one with all of the different things. Just do a bunch of the little things plenty of times and then put them together. Okay, good. That's the first smiley face you've done in a while.
Hey, quantum computing. I looked it up. Derive and differentiate cannot be used interchangeably. To derive something means to prove a formula, and then to differentiate means to find the derivative. So you could derive a derivative by differentiating.
Here in the moment, let's do another one. Nobody else is asking questions, so it's all you.
No. I thought you were Batman.
Sounds good here in the moment.
That's Mr. Batman to you, quantum computing MIT.
The name's Batman. John Batman. I'm not Bruce Wayne. Everyone thinks I am. I'm John Batman. Just kidding, I'm Kermit. I wonder what Kermit would sound like being Batman. That's pretty nice.
Try it.
All right, so I'm going to start as Kermit. Am I Kermit being Batman or Batman being Kermit?
You're Batman in disguise. You are Kermit in disguise as Batman.
All right. So, let's see. I'm secretly Kermit, and tonight I'm going to go out trick-or-treating and pretend to be Batman. So I'm going to put on the mask.
And now I'm Batman, and I'm trying to find Rachel.
How's that sound?
Pretty good.
Please review the derivatives of inverse trig function. Here in the moment, there's
Those are the things you just have to memorize, and
Just-
then you use them in the service of all of these anyway. So what is tan is 1 over 1 plus x squared?
Yeah, it's weird.
right?
Look up. If you just look for like a sheet of derivatives on Google, you'll find cheat sheets of all the formulas you need on those.
I assume your teacher told you which ones you have to know. Yes. So when you have a bunch of memorization things like that, try to relate them to each other. So you have the derivative of tan and things, whatever. Just try to. There's one that's 1 over 1 plus x squared. There's one that's 1 over 1 minus radical x or so. I don't know what they are. Yeah, you
need to memorize them.
You'll need to memorize the derivatives of the cofunctions and the functions and the inverse functions.
Yeah, they're very arbitrary. I mean, yeah.
Actually, cofunctions are easy.
Yeah, even if you understand it, you still have to memorize it. Yes, if you are a mathematical god who truly understands it down to his or her core, sure. Quantum, are you referring to yourself? Do you know the tangent? Sorry. Do you know the derivative of arctangent off the top of your head? Because you truly understand it.
I think I do.
Do you?
Is it 1 over 1 plus x squared?
You might be. It's something like that.
I'll double check. Did my computer die?
Ah. So Quantum does not know. So who is
All
this?
of my devices are dead. So wait, I can use my.
Right. So that does not preclude that there might be someone who does understand it so well they don't need to memorize it. 1 over 1 plus x squared. Yeah.
It is.
Yes. Good for you, Levi.
Yeah, baby.
Yes. Is there a way to derive it? Yes, of course. Is it something that you need to know for your test tomorrow? No, absolutely not. Absolutely not. No, definitely not. Definitely not. I wonder. I wonder. So,
We didn't pick up. Are you deriving it right now?
I want to see.
I'd be extremely impressed.
We'll see. It's gonna take me a sec. Keep doing stuff. Don't look at me.
Okay, so let's say we have 2 tan inverse of x. Let's just start simple like that. Horizontal tangents are when the equation equals 0. Horizontal tangent line, yes. Well, you can have a tangent wherever. Those are critical points. Okay, so yes, if the derivative equals 0 at a point, then yes, that is where the tangent line is horizontal. Yes. So here, we're going to take the derivative. It'll be f prime of x equals, the 2 is just there, times 1 over 1 plus x squared. And that's it. So it'll be 2 over 1 plus x squared. Now, if you're going to have something where you have product rule, then you just do product rule. So let's do that real quick. let's say that this is, let's say 2x. 2x tan inverse of x. So that'll be derivative of the first thing, which is 2, times the second thing, which is tan inverse of x, so nothing changes, plus the first thing, which is just 2x, times the derivative of the second thing, which is 1 over 1 plus x squared. And that's your answer. It's not pretty, but that's what it is. Yes, arctan is the same thing as tan inverse. Yeah. So that's product rule with it. You could do, let's say you have tan inverse of 2x. Well, then the derivative of that would be 1 over 1 plus 2x times 2, right? Because you do the derivative of tan inverse, and then you do then you multiply by the derivative of 2x. Make sense?
Did you answer the horizontal tangents are when the equation equals 0?
Yeah, I did.
Okay.
Or I wanted to specify that it's not, I didn't know what equation it was at first, but it's when the derivative equals 0 specifically.
Yeah. Right.
Okay, so you made this, you have that, that's tangent of, or theta equals tan inverse of that. So theta plus that equals all of that. Sure.
So you're trying to find d theta, and that would be, yeah, this is not going anywhere for me, unless you can see something. Oh, here the mom's. D theta.
So tan inverse is going to be 1 over 1 plus whatever is inside the parentheses, right? So in this case, it's N3rdish, as you can see. But it's whatever's in there you put in the bottom of that fraction. Bye, chemist. Have a good night. So you put it at the bottom of the fraction, and then we have to multiply by the inner function, which is just 2x. So basically you want to kind of be stupid for, like, that's how I actually think of it. It's not 2x squared. No, we didn't start with 2x squared. We have that. So it's going to be 1. Oh, I'm so sorry. Yeah, my bad. There you go. Totally my fault. Yeah, should be 2x quantity squared. I am very sorry. Good catch. I apologize. I do know that when teachers make stupid mistakes like that, it makes learning much harder. Fault. How can we get to there? 1 over that. Well, Bird, let's work backwards. Maybe we can figure it out. So we have dy dx times 1 plus x squared equals 1.
Oh. I'm looking at this right now. Okay.
Good. So it sounds like you got one right that I actually got wrong. So that's awesome. You defended yourself. Oh, that makes it so much easier. Oh no, you did that already.
No, I did not.
Yeah, no problem.
Yeah, this is it.
Do you want to do one more? Okay. What do you want it to put? I can give you one to put it all together. So we can do some natural log stuff. We can do, and then all there is left is to practice for you and also memorize the pieces you have to memorize.
This is rather elegant. Over cosine. So instead of this, it's that over that, and then you square that. Oh yeah. Oh yeah. So they just undo the arctan, make it back into tangent, and then take the derivative. And then implicit differentiation gets you to y prime, which you then use your triangle for. Oh, that's nice. Yeah, I guess if you truly understand it.
Good luck doing that.
Psh.
It's 8:52. I have a child at 9.
Oh, you do?
Yes.
Okay.
Are you working on that as well?
No.
You want to close up the stream?
Yeah.
Very good. Here in the moment, what you just got from Levi and me is pretty valuable. Some free tutoring. Some people wait a lifetime for a moment like here, in the moment. Good luck tomorrow. Levi's gonna finish out the stream. I gotta close up. Wash all the glasses.
Let's say 2y squared times cosine x y equals I don't know how well this is going to work for implicit differentiation, but we'll see.
Hey Levi, here's to looking at you, kid.
I don't know what that means.
Just froth your brow.
Useless, utterly useless. And then let's put a natural log of tangent inverse of 3x to the negative 2 power. Okay, so this is real messy. Do the left side. Try the left side on your own first. I'll give you a minute while I erase this. Remember, anytime you take the derivative of y, you got to get the y prime. This is really hard, actually. Honestly, maybe try the right side, actually. The right side's easier. Do whatever you want. I will begin slowly doing this. So we got product rule because of that multiplication. Oh boy, this is very scary. Let's try the right side first. It's a little bit more straightforward. So this is going to be we have three nested functions. We have natural log of something, then inside that we have tangent inverse of something, and inside that we have 3 to the negative, or to the x negative 2. Yeah. So In this case, we're natural log. We take the derivative of that, which is going to be 1 over what's inside it, which is tan inverse of 3x to the negative 2. We don't have to mess with any of that. Then we're going to multiply by what's inside the natural log, which is everything in here. So now we have the derivative of tangent, which is 1 over 1 plus x squared. So we're multiplying by 1 over 1 plus this thing squared. So there are ways to simplify this, but that's fine. 3x to the negative 2 squared. Then, so now we have derivative of natural log, derivative of what's inside it, which is tan inverse derivative, and now we have the derivative of the innermost function, which is going to be negative 6x to the negative 3 power. So that is the derivative of the right side of this function, which is pretty horrifying. Do you have any questions on that? I shall begin the left side, which is a terrible play. Oh, yes, wait. I'm waiting. What's up? I could have made a mistake. I don't think I did, though. The power rule for 3x to the negative 2. Can you do it again? Sure. So, when you have 3x to the negative 2, you bring this guy and you multiply it by that, right? So you get negative 6x. And then whenever you're doing this power rule, you have to subtract 1 from the exponent, and that brings it down to negative 3. Just like if you had 3x squared, and that's a positive 2, you get 6x, because this would be 2 minus 1 there, which is 1. Does that make sense? So anytime you have a negative exponent, it just goes more negative. It does not become 3x to the negative 1. It becomes 3x to the negative 3. Okay. Now the left side is tough. So first we do the derivative of the first piece, which will be 4y. And now we have to do, so it's 4y, you bring 2 down, but now we have to do, it's essentially chain rule. You can ignore that though, it's just y, right? How do you deal with it when you're doing implicit differentiation with y? You have to multiply by y prime. So I'm just going to write that like that. 4y times y prime times all this, so that's times cosine of xy. Right? So that's the first part, that's the f prime g of that big product rule there. Now we're going to have to add 2y squared, right? The first one times the derivative of the second one. What is the derivative of the second one? Derivative of cosine is negative sine. So it'll be times negative sine of xy. But now we have to do chain rule, the derivative of what's inside the cosine xy. Well, derivative of xy, that unfortunately is going to be product rule again. So we have product rule, within it chain rule. Within that chain rule, we have another product rule with just the xy, which is a lot, and probably much harder than what you'll have on the test. Now okay, so this is the end of it now. What is the derivative of xy? That's going to be product, so we're just taking that last derivative. That's going to be derivative of this. I'll just write it down here first. Will be 1y, right? Derivative of this times this, plus derivative, or this x times the derivative of this, which is just y prime. So we get, in parentheses, y plus xy prime. So this is now, this derivative is now finished, aside from, you got it. Awesome. Good job. So that's really hard. You see how breaking it down works? As long as you keep in your mind what each step is, if you know product rule backwards and forwards, if you know, I guess, quotient rule, power rule, chain rule, if you know all of those, then just do what has to happen, whatever you recognize. If you have two functions multiplied together, you're going to have to do product rule. If in the service of product rule you have to do chain rule, be okay with that. Okay, I'm glad I could help. Normally we do SAT, ACT, but this was fun. I will see you tomorrow, and you can ask more stuff about this, or, lament how difficult your test was, or laud how exciting and easy it was. Who knows? Okay, have a good night here in the moment, and anybody else, and I'll see you tomorrow.